Good morning. This is Andy Schweitzer. Short video here on one of our trends of ionization energy. So a couple things we'll look at here during this video is what is ionization energy? What is the trend of ionization energy? How does Coulomb's law affect ionization energy, and how do the ionization energy of ions compare? So first things first, let's take a look at what it is ionization energy is and how it governs with Coulomb's law. So we have a nucleus in the center, and we have energy levels that are pairing out. So with that, we have electrons that are located at certain levels, and of course this is a crude model of the atom, but we'll go with it. So Coulomb's law is the force equals charge of the nucleus, charge of an electron divided by the distance squared. And of course we're not going to do any actual calculations, so I'm going to go proportional as opposed to putting an equalizing constant in here. So to remove an electron legitimately is looking at the charge of the nucleus and then the distance between here, which is called atomic radius. We also could have a slight drop because of what we call shielding, which would be these guys blocking, which is quite legitimate, blocking some of the positive attraction. So essentially there's two factors. It's just that the charge on an electron is static, it's not going to change, so this is locked, just the charge on the nucleus and how far away it is. That's going to be the amount of energy needed to remove an electron. That's if I were just to have another atom come along here that has a proton, and it has its own, I sometimes refer to as a tractor beam, where it's radiating positive attraction towards these things. And if this atom got close enough that the attraction of this electron to the other proton could be greater than just to its own nucleus, in which case the electrostatic attraction would pull it towards this atom, and now it would be held at a tighter rate or to a more stable state than in its current position. Either way, so that is a general explanation, but what is ionization by definition? Is the amount of energy needed to remove an electron. Now, we also, this would be by definition, you could say to remove the first electron would be the first ionization energy, then you move a second electron would be the second ionization energy, and then so on and so forth. We'll talk more about that in a moment, but a few things just based off what we've talked about already here on as far as the trend is concerned. As atoms get bigger, they get larger as they go down. That should be apparent from the last video, but they get larger. So therefore, because the distance increases, that means that the force of a need to remove it drops. So ionization energy is going to increase in this direction. Increase. And why? Well, simply because it's a smaller atom. Therefore, it takes more energy to remove. And of course, well, not of course, but just so you know that atoms actually also get smaller as you go to the right. So I'm going to go this way. Atoms get larger as you go within a row. That way, that was explained as well. Therefore, just proportionally, it's going to get larger, so larger size. So therefore, a larger ionization energy goes this way. So this is just simply size would be smaller atoms up here. This would have one of my larger ionization energies right here for helium. This would be very large ionization energy. And the one with the lowest ionization energy, I'm not saying helium is the highest because technically, well, hydrogen is smaller, But helium also has a larger amount of protons. So either way, smallest very well could be the biggest atom, and find my cursor here, and therefore this would be the smallest ionization energy. Increases to the upper right hand corner. It's going to increase in this direction within a row, and it's going to increase as you go up. So this is the highest ionization energy. Why? Smallest with the essentially smallest radius, and of course larger number of protons as you move to the right as well. So we've already talked about what ionization energy is, the trend of ionization energy we've talked about now, House's law effect, definitely talked about that. How is ionization compared to ions? Okay, so in this sense, we have an atom. Okay, and I'd say let's go with let's say oxygen versus oxide. Okay, or technically, well, let's leave it at that. So in this case, this atom here has 8 protons, and this one has 8 electrons. This guy has 8 protons, and this guy has 10 electrons. So the question is, who would have the higher ionization energy? Okay, now, as a general rule of thumb, okay, removing succeeding, or I could even go with, let's say, succeeding, let's go removing second and third electrons are always harder, more difficult, more, let's go difficult. Of course, by difficult, you'd want to say is increasing the amount of energy needed to remove. So I would expect that this guy's oxygen atom, its outer electron, is easier to remove than, let's say, this guy's. And you want to look at a couple things here. One is just radius, and they both have the same number of protons. So now we're looking at just distance. This guy has lost 2 electrons, so I actually have it's gained 2 electrons here. In this case, we have our nucleus, and we have this outer layer, which originally had 1, 2, 3, I'm just going to draw it out quickly here, 4, 5, and 6 valence electrons. Okay, pause nucleus here. As I add electrons, I now have the same number of protons, but I now have 2 more electrons. And this is really basing off the atomic radius, that as I add 1, 2, 3, 4, 5, 6, 7, and 8, okay, not a very good picture, but as I add more electrons, my radius increases ever so slightly because electrons will repel against each other. The fact that it is getting slightly larger means my distance is slightly bigger here, and therefore my ionization energy will drop slightly. This will have a slightly smaller ionization energy than would be for the planet oxygen, purely because of a larger radius. Now, I could have another example where I were to take, let's go the other way and let's remove electrons. Okay, let's go with calcium, which has 1, 2 valence electrons, and let's go calcium 2+, which has now lost all its outer electrons. Calcium, in this case, would have a couple energy levels like this, and have 2 outer electrons on its outside edge. Those are my 2 valence electrons. Now this particular calcium would look slightly different. It would have its inner energy levels, but that outer electron is gone and now exposes a full inner shell. Of course, it's more stable like that. But because of the loss of this energy level, all right, notice it's not present, my distance now for the next electron to get pulled off is extremely higher. Okay, so in this case, the ionization is going to be much higher due to the drastic drop in radius by the loss of that energy level. So always keep in mind, as I add electrons or as I remove electrons, what's happening to my radiuses as far as my energy levels are concerned. Thank you very much.